My name is Lalit. I've been working on Android performance and specifically on Perfetto for around 8 years now, all in Google. Today I want to talk to you a little bit about how Perfetto can do more than just view Perfetto traces. It can also view other types of things in Linux, common things like ftrace or Perf, and actually some of the very new kind of feature it has to be able to visualize multiple traces on a timeline at the same time, which is like a very like a pretty cutting edge feature landed in the last few weeks. For those of you who are unfamiliar, Perfetto is fundamentally a suite of tools. So it's not just one thing, but it's actually the amalgamation of a bunch of different things together. Like the center part is kind of what is sort of the core of Perfetto, and then there are other things which kind of feed into us as well. So we have some recording tools, which are we have an SDK for C++ apps. We have a daemon which can collect data from ftrace, whole proc, sys, various interfaces on the kernel to collect data, and then also like a central daemon which can amalgamate data from multiple processes into a single trace file and output it for later analysis. And then there's our protobuf format, which is a high performance native format designed for mainly consumption by our tools, but other tools parse it as well. And then at the kind of center, which is kind of doing the conversion in some sense to something which can be analyzed, mainly because the protobuf format is very efficient to write, but not to analyze or consume. And then there's the trace processor, which kind of parses the protobuf format, but also a bunch of other formats, which I'll explain, and then it exposes that to the Perfetto UI, which is what most of this talk will be about, and also Python API, where if you want to do ad hoc scripting or analysis, this sort of thing, then the Python API, you can just use it to like run the same queries. And then there are some things which are kind of on the outside, which are pretty important to this talk as well. So one thing is that there's a bunch of other formats as well out there, right? Which are used by the Linux community in general, and also by people who are looking at performance. So perf.data, ftrace text format, the Firefox profiler format, many others out there. Quite a few of those we support ourselves, and then also. There's the Chrome JSON format, which is what was talked about earlier, which is also like a simpler interchange format. It's not the most efficient to read or write, but it does the job for a lot of use cases, which people use Perfetto for. And then often the thing is that people write converters, so they have their own kind of own tracing, whatever that format might be. Maybe it's some proprietary format, maybe it's a format we don't know about, and it's very common that people convert to one of the formats that we understand. Most commonly are protobuf or JSON formats, and then the trace parser can handle all of these things, right? The Perfetto UI. The Perfetto UI is fundamentally a web-based trace visualization, which runs 100% locally in your browser. And so it's a combination of timeline visualization, user-driven aggregation and operations, and then SQL queries, all in one interface. And as I said, because it has the trace processor as like a backend, it works with a bunch of different trace formats, and it's open source and developed on GitHub. Everything. Recently, at the start of this year, we actually moved our whole development to GitHub. So in the past, we used to kind of develop in Android, and then GitHub was a mirror. That's no longer the case. GitHub is actually where we develop, take pull requests, etc. At this point. There are some misconceptions that often people have about Perfetto, especially because it's a web-based system, and as soon as people hear web, they're like, oh my god, which are you sending it to some server, and does Google have access to my traces or whatever? And the answer is no. So everything happens inside your browser. There is no trace data that never leaves your system. It is processed entirely locally. If you want, you can turn off networking, and Perfetto UI will work just fine on your machine. No backend needed. As I said, fully offline capable. So you just need to load it once, and every time after that, you'll just be able to use it without any problems. It doesn't require adopting Perfetto tools. Same reason, because we support a bunch of formats. You can convert to Perfetto or otherwise, and it doesn't require you to adopt the Perfetto format. As we say, we support many other formats out there as well. So most of this talk, I'm going to spend actually showing you how we use the Perfetto UI to debug. But I know that like the sort of things that we often are debugging require a lot of understanding of Android internals to even understand like what's going on. So I don't want to show you something where you're like, oh, that was cool, but I didn't really understand what was happening. So I actually came up with like a demo program basically to show this off. A lot of the ideas in this are realistic, but it also means that you can try it for yourself. I worked on this over the weekend. It's a Rust program which generates a Mandelbrot set or Julia set and visualizes it over time, right? So the technologies I used, Rust, Vulkan, there's some GPU rendering, CPU compute thrown in there, a bunch of different things. It's also multi-threaded, so a bunch of computation is happening on background threads, and then that's being passed to like the main thread for rendering. And then obviously, for demonstration purposes, there is a bug there. The bug is that it should run at 60 FPS, but every so often the frame rate drops dramatically. And actually, I can show that off to you. So if I go to here, my thing, and then I run the program. This is the Mandelbrot visualizer. I don't know if you're going to be. Yeah, you just saw that there's some like frame drops there. It's also not very good because Teams is also frame dropping at the same time. You like on my machine, like there are some very obvious places where it drops frames. The frame rate goes down from 60 FPS, which is what it normally is, to something much lower, right? And so the goal is to figure out what's causing this, right? Like why is this happening? So yeah, and the code is on GitHub. You can try it for yourself during or after the talk if you're interested in following along. And the traces are there as well. So I'm going to show off some traces very soon, but you don't have to collect the traces yourself. It is there, but you can collect them if you want. So the first thing will be maybe it's like some CPU problem, right? Like so, a lot of engineers in kind of doing like the sort of people I work with, at least in my thing, they reach for perf immediately whenever they see like, oh, like there's some problem. If the main reason is because if it's CPU bound, they can go straight to the line of code, and that's like very nice for a lot of people if you can just tell them where something is without needing to like read a trace and figure out. You can record a trace with perf record. I'm using kmono, spoiler alert, that's because for some things later you don't have to, it will work just fine without. And then like the kind of standard way, which I think a lot of people that I know kind of do for this, is they generate SVG out of flame graph PL, right? Like that's what the kind of gold standard is in some sense for this. And for Perfetto, if you want to load it there, you just actually need to redirect the output of Perfetto script to a text file, and that's all you need. I can show off, actually I think I closed the tab accidentally, which had flame graph PL, so I will need to reopen that. So this is what the flame graph PL looks like for this program when I profile it. So you can see that, if I'm guessing most of you have seen one of these before, but basically, at the bottom you have the threads, and then you have the kind of stacks of what the program is doing. One interesting thing I noticed is that it doesn't seem to support Rust demandling correctly, which I thought was a little weird. I would have thought that it would have worked, but it was a bit strange. But in any case, there's a bunch of different threads. You can see these are the worker threads, like each of the workers is running there, and most of their time they're spending doing cost and sign operations because they're doing some math computation, basically, what you would expect for this sort of program, right? From looking at this, nothing really stands out to me. I mean, obviously you don't know the code base, so maybe that's not the same for you. But if I was looking at this and I knew my code, I would be like, I don't really see anything here which doesn't look normal, right? There's not some smoking gun here, which is like immediately I'm seeing the problem. One thing about perf, or this sort of visualization of perf, is that it loses the time dimension, right? You have aggregates, but it's aggregates over the entire trace. So the thing that I have in my trace is that I'm getting a frame drop every 2 seconds, 3 seconds, right? Most of my time of my program is actually spent doing the right thing. So how do I find the places where it's doing the wrong thing? Well, that's maybe where Perfetto can help you out a little bit. So if I open up the perf text format, and then I expand all the things. So I'll just show you. I'll just briefly explain what you're kind of seeing. Every kind of line here is both it's a thread really, and each of these arrows is one sample on the thread, right? So you can see there's a bunch of threads. It'll look a lot more interesting when I scroll down and I get to the threads which are actually doing work. So there's a bunch of threads in my program which are just Vulkan background threads. Most of their time is spent doing GPU related things. They're not doing anything on the CPU. But this is what the workers specifically are doing, right? So if I can zoom in and out of the UI, and as I zoom in, I'm getting like looking at a smaller region of the trace, and there's some very interesting thing going on, which is that you can see for most of the lifetime of the program, it's doing continuous computation basically, right? And then there's this kind of period of time where there's this very interesting staircase sort of pattern where it seems like only one thread is sort of running at any one time, which is a little interesting. Maybe something to note for the future. And in fact, you can. The cool thing about Perfetto is that you can very quickly look at generate sort of aggregates or visualizations of aggregates of what you're selecting. So we have this notion of what we call area selection, which is where you can basically drag your mouse and you can essentially select on a single kind of timeline or even across multiple timelines. So I can do kind of aggregates across the three threads at the bottom, and at the top it shows you like how big the aggregate is, and then you can also see at the bottom the kind of flame graph or flame chart. Excuse me, but I still don't quite grasp the difference between the two, but I don't know which one this is. But whatever this is the kind of aggregate of this time, right? And in some sense, this is the same. Sorry.
So that's a flame chart.
Flame chart.
Flame chart is where it's time-based. Flame graph is not duration altogether.
Watch your video.
Okay. So the cool thing is that I can go and look at individual regions of time, right? Unlike flamegraph.pl, which I know that there are ways that you can pre-filter the kind of flame chart to what you're looking for, but that kind of assumes that you know what you're looking for before you find it, which is I've always found that a little counterintuitive that you filter before. So I like personally, I prefer this view where I can see like everything, and then I can be like, I want to look at this in more detail. And that's kind of what Perfetto lets you do, right? And so the flame chart, I spent a bunch of time in Google. We have internally a tool called pprof, which is not the same pprof as you have in open source. There is an equivalent, but I've always loved the kind of visualization that we have there. So I spent a bunch of time getting this to look exactly or behave very similarly to that. So there's a bunch of features here. You can highlight specific nodes. Probably it's better if I go to a slightly different place. So you can obviously zoom in, which is kind of normal for most flame charts can do this. But you can also be like, I want to only look at the kind of stacks starting from this point, right? So there's this kind of visualization which gets rid of everything else above and then starts at this point. There's ways that you can essentially say, for example, I didn't want to see sign at all. I can just hide the frame and then just get rid of it, and it gets merged into its parent. There's ways where you can, show specific stack regions and stuff. It's very powerful. There's also regex based, so you can look for a regex for the sort of things that you are interested in some sense, right? Yeah, it's a pretty cool thing. And then there's something that I'm not sure I've seen any other particular visualization of this. So it's what I call bottom up, which is, imagine you take all the leaves of across your entire program, and you sort of visualize who is calling into that, right? And so if you have like a leaf function which is called everywhere in your program, but you reach it by many different places, it'll be like kind of split amongst your flame chart, right? This is the inverse flame chart in some sense, right? You're looking at the leaves and you're like, who is calling me, right? Which is a pretty interesting visualization when you're trying to optimize like very low-level functions. So if you're optimizing something which is always at the leaf, memcopy style functions.
Hash
very
get.
Sorry?
Hash get. That's
Yes.
one of the classic.
Yeah. Which hash maps are exactly causing print? This is what this lets you do. It lets you find the stack which found this. So
iceberg chart.
sorry.
Iceberg chart.
No,
Iceberg chart.
Don't say that.
Okay. Don't know what the context is there, but okay. Yes. So yeah, this is quite a powerful feature, I think, and I've heard good feedback since we implemented it. But there's like a lot of things you can also, of course, you can see also the main thread. If I go back to our problem, deviates a little bit on the on the tool, but like if you go back to the thing, you can see also the main thread is also kind of not doing anything in that time region, which is very interesting as well, right? So if I go back to the presentation now. Cool. So the CPU gaps indicate generally that there's some sleep happening, right? Like, the sort of staircase pattern where you're not doing anything on the CPU at that time, that's usually a sign that you're sleeping. So, but what are you sleeping on? Like, are you sleeping on locks? Are you sleeping on I/O, synchronization, like something? Like, what's exactly happening? So you would need something like a scheduler trace to tell you, like, what are the wake-up patterns? Like, who is being scheduled when, etc., right? What type of sleep are you in? That sort of thing, right? And so very recently, we added support for TraceCMD's text format. There is an open issue to support the binary format. We will do that, but we will get there in the near future. And so I'm collecting sched switch and sched waking events here. I can show you what that looks like now in the UI. So this one's a little slower to open mainly because you need to parse the sched trace using regex, which obviously kind of sucks, but it's not as fast as the perf one to open. But this is the kind of view of a scheduler trace, right? So at the very top, you've got the CPU scheduling track. So for each CPU, what was scheduled at each point in time. The white regions are, where there's nothing scheduled. And as I zoom in, you can start to see, okay, there's some information like the kind of name of the, I can probably zoom in a bit, the name of the thread which is scheduled, like the TID of the thread, etc., right? And then if I go down, so this is the kind of CPU view of things. So if I'm looking from a CPU perspective, and then there's also the kind of thread view of things, right? So the thread, what we call the thread state. So what was the scheduling state of each thread at every point in time? And you can see that there are some very clear running, runnable, sleeping, running, runnable, sleeping, and so on, which is the standard sort of pattern. But if I zoom out, okay, well, again, there's a button here to expand all the tracks, by the way, as well. I don't know if anyone uses the UI. That's a very useful button. But you can see, again, you're seeing the very similar pattern, and you're also seeing that it's definitely because of, so the white regions are interruptible sleep for us, right? And then there's orange regions, which doesn't show up really in this trace. Actually, it shows up maybe here. There's uninterruptible sleep, which is in D sleep or equivalent, and this is what we refer to as interruptible sleep or S sleep, right? You can see, okay, there's a very clear like staircase-like pattern. Again, only one thread seems to be running at any one time. Kind of, you're maybe getting the sense of what the problem might be at this point, I guess. Yeah, this is sort of what was happening, and you can see in the times where otherwise it's sort of completely, it's running as you would expect. As with the perf visualization, you also have ability to do area selections and stuff here. So if I do on the CPU one, I can get kind of tables which tell you like the time spent by each thread. This trace doesn't have process information, so we don't know what processes things don't belong to. This is a very important thing in Perfetto. We always try and make sure that if we don't know something, we don't pretend like we know something. We'll just tell you we don't know it. So that's why this is empty, right? Because we ftrace traces don't tell us process information. You would need to scrape proc or something to get that information. So yeah, you can get this, and then you get the same thing on the sched visualization, on the thread state visualization as well. You get something very similar. You even get a nice representation, which is, you can see runnable time is basically negligible compared to running and sleeping, which is where most of its time is being spent. And then there's also a few things for if you're interested in specifically scheduler-related things. So we have like run queue length. So what time are you spent in running runnable? Like how many threads are runnable, and also like how many CPUs are active. So you can quickly see that in the region if I pin this track. So pinning is where you can like keep a track open while you scroll around and other things. So if I pin these tracks, you can see in the region where basically like nothing was happening, the active CPU count also went down, which makes sense, right? That's sort of what you would expect to see as well. Cool. So that's what a scheduler trace looks like with Perfetto. So the scheduler shows when threads are sleeping, and it's showing that it is sleeping, but it's not telling us really why, right? Like what was the program doing in that region? Like what code was it running? What was it executing? And sort of sequential pattern suggests some sort of serialization, clearly, right? Something is causing only one thread to run at one time, but we need the application level visibility. Because this program was written in Rust, I just used the off-the-shelf tracing and tracing Perfetto. I did have to do some bug fixes on tracing Perfetto. I'm going to send those upstream in a little bit, but these two crates together basically output a Perfetto trace without needing to use the Perfetto SDK or anything like that, right? So these are maintained by other people. We don't have any hand in them, but these are people who are just running these things. And so I added this capability to my program to be able to output this trace when the trace command is set, right? So we can now look at what that looks like in the Perfetto UI as well. Cool. So this is what it looks like. If I zoom in a little bit, I'll show you what the normal thing should look like. So normally, you're rendering frames, right? That's what most of the time of my program is spent just rendering frames. So that's what the render frame function, obviously, in the main thread is doing. We call these slices. I know different people call them different things. We call these slices. And then the main thread is just trying to render the frame, and the workers are each trying to compute tiles of that frame, right? And eventually they'll kind of feed back to the main thread, and then it'll sync the frame to the GPU essentially. That's what normally looks like. And also there's this thing called flows, which was kind of mentioned earlier, which shows you in this case maybe not the most useful because there's so much computation going on, but it basically shows you the kind of causal links between different pieces of the thing. So render frame is calling into all of these places, and so that's why it's causing it to happen. It's a little bit more clear if I click on the other way, because then you'll see, okay, render frame is what caused me to start executing, right? And that's a pretty useful thing. It's sort of similar to wake up graphs except for sort of user space, right? Like this is what caused me to start running, or this function.
So wait, quick question. Why the arrows start at the end and not at the beginning?
That's a great question. So the reason why is because in Perfetto, arrows always start at the end and not the beginning. The way you would get it to, I didn't have time to fix this. The correct way to fix this would have been to emit like a sub-event, which was the point where the kind of fan out happened, and then the arrow would look more reasonable, right? Like, because I'm basically saying that the whole slice caused all of these things to happen, and we don't want to pretend that any one point of that slice caused it to happen, right? Because in that case, it would be misleading. We could just, as a rendering thing, probably look at from the beginning. That would be valid as well. But I would need to speak to my colleague about exactly why we always choose to do it at the end, but we always do it at the end. Yeah. Yes.
I'm just curious. So the trace event format allows you to put to set the time whenever you want.
It does. However, in Perfetto, we actually just the trace event format lets you do that, but it also says that it captured the parent slice. It doesn't actually that's not what timestamp means in that format in most normal usages of that thing. This is one of the corner cases which is undocumented, but the weird edge cases around kernel tracing and how flows work in that format. It's not what you think it is. It actually says that it binds to the parent slice and it looks like that. And I think if you open in kernel tracing, you'll see the similar thing.
I had a difference between trace compass and kernel tracing because of that. Like we balanced at the time. Sorry.
No worries. There are some interesting things. I think I'm probably at this point the most knowledgeable person I know about the JSON format, just because I've probably fixed about 150 bugs or something in our parsing of that format. Let me tell you, when you try to replace a tool, people will, hammer you with, this is different with this tool that you're replacing, this is different, and we have to spend a lot of time, fixing all the compatibility issues with the old Chrome tracing tool. Okay, so back to the demo. You can see that very clearly that there's a normal region and the region of time where, things are taking 1.8 seconds, which is probably the cause of the frame drops almost certainly. I'm doing this thing called update adaptive quality. So the idea of this was that I wrote some code to basically dynamically change the quality of my rendering based on the frame rate, right? So if I'm running faster, I can render stuff at higher quality, and if I'm running slower, I can do lower quality, and that's what this adaptive quality thing is, right? But you can see clearly something has gone wrong. I'm causing frame drops because of updates to adaptive quality. Just a little bit ironic, to say the least. That's almost certainly the problem. Now we know, okay, this is what the program is doing at a time span. So we can go back to the thing. So we've looked at these things separately, right? So in Perf, we got told that there are few or no CPU samples and there are weird patterns. In ftrace, we saw that only one worker seems to be active, and the rest are sleeping in interruptible sleep. And in app tracing, we're like, okay, it's because of worker adaptive quality updates that they're working on, and they shouldn't be doing it in this way, right? And obviously, the theory is that it's all the same problem, but we can of course confirm this theory with the very new feature of the UI, which is trace merging. So I can show you what that looks like. For anyone who tries to replicate this, I'm running this on the auto push UI because there's a bunch of features which have got like a bunch of fixes and features as part of preparing this demo that went in. If you want to try it yourself, you go to flags in the sidebar and then you switch this to auto push. And also for this feature is currently gated behind a flag because it's very experimental still. So you would need to go to plugins and enable the multi-trace open plugin, which is here. So you enable that, and then once you do those two things, you will have this thing pop up here, which is open multiple trace files. So I can just select the 3 files that we analyzed earlier. It'll analyze itself, each of the files. At this point, it tries to do like some clock sync and that sort of thing. And then once I click open, it will load all 3 traces, and then it should show us. Cool. So this is now the merge trace file containing all of the different information. So now you can see that we have the CPU scheduling tracks like we had in the scheduler trace. But you can also see we have the stack samples like we had in the stack sampling trace. And then you have the app instrumentation like you have there, right? And all of these are beside each other. So you can very clearly see that, okay, adaptive quality update, it was running, and then there was this period where it ran, and then it was done, right? And you can see it's very cool to be able to see the pattern of, okay, like, this is how long my program is sleeping, this is where it was happening. And the thing is, you've always kind of been able to do this with Perfetto if you collect a Perfetto trace with all of these integrated, right? And the new capability is that this is now being brought to, you don't need to collect with Perfetto. It's fine. Collect it with whatever you like, and we'll still manage to do this visualization, essentially. And that's the new capability that we have. Yes?
You mentioned over lunches, that you have time synchronization already handled. So how would you handle it with the different traces, different clock sources?
That's a great question. There are assumptions about which, for every format, usually there's there's usually a normal clock that people emit things in, right? So in Perf, that's actually the Perf clock, generally. In ftrace, that's the local clock, I think, for ftrace on Linux.
Basically, schedule clock.
Sorry?
It's basically the scheduler clock.
It's a sched clock, yes. And then, in Perfetto, that's boot time. So each of these things have their own like normal thing to emit in. So what we do is, right now, we're assuming that everyone is talking about the same set of clocks, and then in this particular example, I've very carefully chosen monotonic in every tool so that it just works. What I want to do is that in this dialog, when this dialog comes up with the things, I want to let people.
ftrace has a perf clock too.
Yes.
Which is the default perf clock.
Yes. In Perfetto, we prefer to work in boot time because we care about suspend, and we need to care about cross CPU and cross stuff. But every person has their own clock. It's the same as formats. Everyone has their own format. Everyone has their own clock. So what I want to do is have the ability in this dialog to configure or override what we've detected as the default in some sense, right? Okay. So there are some nice formats which tell you what format they're collected in. So I think the perf data format tells you the clock. I think maybe the trace stat.
CTF is very pedantic about that.
Okay, cool.
TreeStat has a clock field in it.
Perfect. So there's some well-designed formats which have this, and there are some formats which are maybe not optimally designed, which don't say.
Yeah, some forget their time zone.
I don't know what that's referenced to, but
No, like you have a time with no time zone, and you're correlating to 2 servers in different countries.
Yes. So for us, the thing is, like, there's some formats where the time the clock they're emitted in is not there, right? So for example, the Chrome JSON format does not have a clock specifier. Most people do not fill anything about clocks. They just assume that they're the only people emitting stuff, and then they emit it. So for those cases, I want to have a way to configure here which clock it is, and also maybe auto detect the kind of it seems like you're using Unix timestamps, that sort of thing. So yeah, that's how we're going to do it.
Excellent.
Cool. So that's the merge trace. So there's also some interesting things in the merge traces here. I did want to like shill a little bit for the SQL query interface while I'm here, because there's some pretty powerful things that you can do with these tables and etc. So as well as kind of the flat aggregation that we have here, we have a more dynamic pivot table and like a table version of this as well. So say for example I go here, I get like a list of all of the events which happened during that time region, and then this lets me filter for things like what like say for example I only care about slices which are longer than some duration, right? I only care about slices which are longer than 319 microseconds for whatever reason, right? I can click this and I can add a filter that filter on things greater than this. And one very neat feature of this is that we have this feature called show debug track. This is very, very powerful. Basically what it lets you do is on the timeline it adds a track off what you see here, right? So you see here there's a bunch of rows with some timestamp and duration information. Wouldn't it be nice if we could see that also on the timeline? So we added a track at the top, which is essentially the regions of time where this thing happened, right? You can see it very quickly, like, oh, like, this is where these things, like whatever you're filtering for. So this is the region where compute tile took longer than this period of time. This is very common in Android, where we're usually looking at this system A and what is the effect of this system A on this other system B, right? And so we usually like find all the places where this thing is slow and then do some correlation. And being able to like have a track in the UI where you can very quickly see and compare, I'm like, oh, okay, during this period of time, this other thing was happening, right? That's invaluable. Like that's probably one of our most used features, I would say, as well. And then also there is a way that you can copy the SQL query from here, and then you can go and start doing your own aggregations or whatever you want on top of that, so that this kind of eases the burden a little bit of starting with like a completely blank canvas, right? So you have this problem of, oh, like where do I even start querying my data? Like what tables is my data in, right? And this is trying to sort of help you with that problem, where it's trying to give you a query so that you can look at this without needing to write something from scratch. Unfortunately, I would have loved to go into the details of querying and stuff, but I just wanted to focus this presentation on one thing. So I'm going to keep it just on the UI. So now back to the actual problem that we're trying to solve. So dynamic updates are stopping the world. Perf profiling showed the problem. Scheduler traces, found it is sleeping. App tracing confirmed it was dynamic quality adjustment. And a single timeline view lets you see everything in one go, what was happening in all that time, right? So actually, very interestingly, I tried to fix this, and then I realized my fix was incorrect, even though I'd introduced the bug in the first place, which is a very interesting experience. So I tried to remove the lock contention, which is the bug that I thought I had. But actually, turns out that I shouldn't have been doing this code in the workers in the first place, and it was right to do it in the background, because even if I removed the lock contention, even just the CPU activity of doing that work in that time was enough to cause frame drops to happen, which is very interesting. That as part of debugging this thing for this demo, I discovered something even better that I could be doing, which was cool. So Perfetto in the open source community. Perfetto has a lot of different tools and sort of people who've built stuff on top of Perfetto or have configured Perfetto in a certain way. I want to call out a bunch of things which we've thought are very cool projects in the Perfetto team. Obviously, like Android and Chrome, that's our bread and butter. That's what officially we support as a team. That's why we get kind of staffed by Google to do that, is for Android and Chrome. But we also Mesa uses as their tracing system. So one thing I could have shown you as well is collecting a Mesa trace and showing that along with all the stuff we see. So you can actually see what the GPU is doing at the same time, which would have been very cool, but I just didn't have time to also do that as well. Vistrace is function tracing for Python, kind of similar to uftrace, but you don't have to compile, recompile or anything or do anything special. pthread trace is very cool. It's for visualizing pthread mutex contention. He has a very efficient way of doing this, and then he writes protobuf using very heavy use of constexpr to make it very low overhead. It's a very interesting interesting project. Magic Trace, which is a project which a few years ago, if you're familiar with Intel processor trace and the ability to do function level tracing at the processor level to lower overhead, someone wrote a converter from that to the Perfetto format, so that then you can visualize that stuff in Perfetto. So that's very cool. Case's schedule analyzer, that's for scheduler internals. He wrote a very good project. This might be also for Steven. I don't know if you've...
I work with them.
Great. So yeah, it's that one's very, very cool. I find that very cool. John Stills wrote an all-in-one recording script for Perfetto. So a lot of times upstream kernel developers are like, Perfetto is so complicated. I don't know what events I want to record, etc. He just wrote a script where it just configures everything for you. And then one thing which is a bit experimental, but I came across this recently and I thought it was so cool, is that like BPF based tracing. So he, Joseph Basic, who's a kernel developer, re-implemented like our tracing daemons on top of BPF instead of Perfetto. He has a blog post where he talks about why, and it's just a very interesting idea. I'm not sure if it's ever going to be like a production thing, but it's as a proof of concept, I thought it was a fascinating use of our thing. So. If you want to try this yourself, you don't obviously you have my demo. You can try it with the program I give, but record it on your own programs. Open scheduler traces and Perf at the same time on your thing. Instrument your program, convert it to Perfetto, and then you can visualize it as well. So if you do want to convert ad hoc timestamp data to Perfetto, we wrote a very comprehensive tutorial explaining, giving you Python snippets for everything that you might want to visualize in Perfetto, all the cool things that I showed, and then how that would look like in the Perfetto, writing Python for that, right? We have a library for writing these things, so you don't need to, beyond one library, you don't need to install anything or anything, and you can go ahead and convert your own data to Perfetto. So the key takeaways, correlation is a killer feature. We've had it forever in Perfetto if you're recording with us, but now we brought that to outside if you're recording your own stuff. So keep your own workflow. So you can. This is trying to enhance your tools. You don't need to change how you're recording stuff. Record with whatever you like and visualize in Perfetto. And we're very happy to accept contributions. So we're Apache 2.0. We're on GitHub. You can just send us pull requests. We will just we review them pretty quickly. We have a lot of open source contributors. We're very thankful for all of them. We've been quite lucky. We've had some very high quality contributions over the years. And so, if you want to contribute yourself, or if you have some feature you feel is missing, then send it our way. So yeah, thanks. This is all links to the various things. And any questions? Yes.
So I didn't understand. If you have one trace that's like first time and one other trace that's a different time, how would you separate the two?
Yeah, so for that specific use case, if there's no bridge, basically, so Perfetto does have the ability to use, it tries to go through all the traces, try and see if there's anything that lets you sync the clocks, right? So if there's some snapshot, so if you're collecting with Perfetto tools, we emit what we call our clock snapshots, which are basically a snapshot of all the main clocks in the system. And that lets us essentially go however we like, right? Converting from anything to anything. If you're collecting two different traces, neither of them have any clock information, we're going to just have to ask people to specify offsets, essentially, right? There's nothing better we can do. The thing, as well as the thing I just showed you of going to the UI and manually selecting the traces. One use case that a lot of people that we know have is that they're collecting traces in lab tests, like in like benchmark runs or whatever, and they're like, oh, I have like a recording on. I'm using Perf to record this, and I'm using scheduler trace to record this, and then I don't want my users to have to go to your tool and open both simultaneously. So the cool thing is actually you can just tar these two files or zip them together, and they will just open as if they were like seamlessly in Perfetto. You don't have to do anything special conversion steps or anything. We're going to have like a JSON. If you're doing that, we're going to have a way with a JSON kind of file to tell us clock offsets. So that takes care of that problem as well.
And will it be possible in the future to define some events as effect and pause, and then do sequencing like after the fact?
So Yes, the way that we would do that in Perfetto is that we would not put that in the trace itself, right? We would put that in the UI in some sort of using some SQL queries where you can be like, okay, I'm gonna like build this analysis on top. So one thing that I didn't show you in this demo because I would say our kind of ability to do these things for people outside of Android and Chrome is not very good. Is the ability to do automated kind of there are kind of what we call UI plugins, which is I think a bit similar to like the idea is similar in Trace Compass as well. You have the way to have pluggable analysis essentially for people. We have that in Perfetto as well. The only thing is that because that API is not stable, you need to land code in the Perfetto repo, which is obviously not is a deal breaker to a lot of people, right? For Android, we've managed to convince a lot of Android people to land code in our repo, and if you open Android Trace, a bunch of things automatically happen for you. You can have commands which do automated things. So one thing I didn't show in the UI, I can show, is that there are a ton of this is what we call the command palette. There are a ton of different actions here, which are different analyses, kind of snippets that people have written to be like, run this thing on this. For arbitrary things, I think our support is still pretty lacking, but it's an area we do want to invest in over time.
Just for giggles, I just opened Perfetto from Chrome. I opened the command palette.
Yes.
How many more things do you have in yours than I would have in mine right now?
So if you open an Android trace, you should just have the same. But there's a lot of commands which get added on a contextual basis. Okay. So they're like, there's detection of if this trace has this event, then add this command, right? Cool. You can do that sort of thing. Because the way it works is the plugin interface is just basically like you get a little bit of a few hooks, and then you can kind of do whatever you want in that hooks. So you can run arbitrary JavaScript. Yeah, like people do like, oh, if they detect the count of this set of events is greater than 0, then run this thing. Then yeah, that's how it works.
So do you have a way, when looking at a list of possible plugins, to query what information am I missing in this trace in order to be able to use that plugin? Is there a way to discover them?
No, that's a big problem actually. It's an area that we're very aware of. It's actually a problem throughout the entire Perfetto stack, I would say, which is that people often come to us and they're like, someone gave me this trace and I see this event in the trace. How do I get the event in my trace that I'm recording? And the answer is there's no good way. It's all just tribal knowledge inside of the Android org. There's a bunch of knowledgeable people who are on chat rooms who these questions are asked. They'll be like, oh, you need to use this event. I would love if there was a way to basically go backwards, right? So from an event, go to the SQL table. From the SQL table, go to the record the thing that you need to record, etc. And that's sort of. I would also want it to go to, like, what is the command that if I had this thing. I mean, I guess you want the reverse of that in some sense, right? You want to be like from command what.
It could be you have a set of plugins you would like to use. Yeah. You select those, give me a profile that would enable the tracing and the various tools I need in order to populate the data for that set of plugins.
Yes, that would be quite interesting. I guess because plugins are like an implementation detail, so people don't really think in terms of plugins.
Or I don't know how you call it.
Yes, but there are definitely situations where we are. I think the closest analog is what you're thinking of is what we call a workspace, which is like a way to have a dynamic view of the UI. That's quite an advanced feature, and it's kind of underutilized at the moment. But when we get to that, we definitely want to get to a state where we're like, these are the things that you need to do in order to make this view work, right? That's definitely a priority, yes.
I just tried the UI, the web UI, and
yes.
If I check off the additional categories and high overhead categories and start a trace on it, it will crash after like 1 or 2 seconds.
Are you recording a Chrome trace?
Yeah.
Okay. Yes, you can please follow back about that. We will look into it. I mean, I would imagine the reason why is because the high overhead categories are so high that you're causing Chrome to basically die. If it's on the recording side, it's probably not our team. We would need to route it somewhere inside of Google. I don't even know which team I would route it to if you enable all the categories, because then I don't even know what's the problem. Follow back. We'll take a look.
For the trace synchronization, have you tested with virtual machines, so tracing the host and guest and correlating procs?
Yes. So That's a very interesting question. So inside of, if you collect, there are ways to record Perfetto traces with VMs. There are some people in Android and Chrome OS who have wanted to record across machines VMs for ages. And indeed, Perfetto, if you record using Perfetto tools, there are ways to basically visualize cross-machine in one timeline. Yes. However, what's missing is I collected this independent trace on machine A, I collected this independent trace on machine B, I want to merge post facto. That is on my to-do list for the next thing that I want to do for merging is in fact that exact feature, is cross-machine merging.
Okay, but there is a feature to make it work if you record both.
There is. It's a very arcane because it basically relies on a bunch of steps which I don't think are documented anywhere. But there's a daemon called traced relay. If you are interested, there's a daemon called traced relay that you need to run on your virtual machine, which forwards over like there are a few types of things that like a few types of network or kind of socket protocols you can forward, and then the trace data gets forwarded to the main daemon. Like one of the machines is considered main, and everything else is got feeding data to it, right? And then once you do that, yes, you basically get a merge trace, and that works today. It's being used in production by Chrome and Android. So.
Thank you.
Cool.
Thanks a lot.